Okay, so last week we studied a little bit about how we can generate three-phase power. And we also learned that three-phase power really is the most efficient way to distribute power to factories and homes and many other usages. All right. So we can take that three-phase power and convert it into single-phase powers or a number of different types of single-phase powers. That's usually done by using transformers, which is today's subject. Okay, but today's subject is mainly a preliminary subject to discuss single-phase transformers. So we'll learn how to transform voltages from high voltages to low voltages, which is a step down, or from high voltage to even higher voltages using a step up technique. Okay, uh, and we'll learn all of the equations that are necessary to do that. We'll do a few problems on the homework to just get ourselves acquainted with how things work with transformers. But these are single phase transformers, and they can they can be used for three phase, which we will talk about tomorrow. But so that we can actually get three phases and using transformers to get transformed single phase units. Okay, we'll go into that tomorrow. In the meantime, there's one other thing we forgot to mention of yesterday's is the power factor. Power factor we like to use. We like to have our system operating at power factor 1. Why? Because if it's inductive loading or if it's capacitive loading, we lose some power by reactance, VAR units. Okay, we want to shrink that VAR to as small a piece as possible, so we get closer to unity power. So we get unity power factor when true power is equal to apparent power. So, but if we have an inductive power, okay, the inductive power gives us a positive angle, positive theta angle, whereas a capacitive power gives us a negative angle. So if we run a system where we have a lot of inductive power being used up, we can compensate for that by adding some capacitive power to it to reduce the amount of reactance. So we've seen back in the last course that we took that if our inductive reactance is equal to our capacitive reactance, what do we get? We get something close to resonance. Okay, and what does resonance do? Well, resonance eliminates reactance. Okay, and basically the power we absorb is the power that we use back and forth. So that is why we can compensate for power factor if our power factor is below 1. Okay, so if it's below 1 because of an inductive reactance, we can add some capacitive reactance in line with our inductive to create a net zero effect and get closer to a power factor of 1. Okay, but today we'll just look at the preliminary transformer. We'll do a few problems, and tomorrow we will get into how to use transformers for three-phase work. If you have any questions, give me a call, email me, or whatever.